Well, my lovely grade 11 class.
What's up?
Oh, yeah. You're like having like a little extra...
Yeah, because it's Friday. I'm almost out of here.
Like he's busting out. Okay. Solve. So the last topic we did was solving. And I'm going to say solve. And I'm going to give you 12 equals negative 3 plus 5 square root x minus 8. And I want you to state restrictions and solve for the variable. And what do you always have to do when you're solving these? Your very last step is to check. So the first thing we're going to have to do is isolate the radical, correct? And how we isolate the radical is we do reverse bedmass. So we either have to move the 5 or the negative 3. The 5 is multiplied. This is a subtraction. We do the subtractions before we do the multiplications, right? Reverse bedmass to get that radical by itself. So we're going to add 3. And so we get 15 equals 5 square root x minus 8. Okay? Then we have to divide by 5. Three equals square root x minus 8. Then I told you, once you have the radical isolated, how do you get rid of the square root? You start from this.
The square root.
Yeah. You need to square it. So we're going to go square the 3, square the square root, and it goes away. And we get 9 equals x minus 8. And then we have to add it. So we get x equals 17. Now remember, we don't box it because it could be extraneous, right? We have to check these every single time. So, remember, not extraterrestrial, extraneous. So we have check.
Can I get half the marks if I say that?
No. It won't happen. So we're going to check it, and we're going to get 12 equals minus 3 plus 5 square root 17 minus 8. Remember, we always plug our checks into the typed version on our test, or the written question that I gave you, right? Nothing that you've touched because you could have made an oopsie in it. Now, we get 12 equals negative 3 plus 5 times root 9, right? And 12 equals negative 3 plus 5 times 3. 12 equals negative 3 plus 15. 12 equals 12. Is that true?
Yes.
Yes, and we have to go to 12 equals 12, right? Because you have to be able to have like a 4-year-old look at this and say, yeah, those are the same thing. The previous step, 12 equals negative 3 plus 15, a 4-year-old wouldn't say, yeah, those are the same thing. They'd be like, mm-mm. Right? So 12 equals 12. Get. Yep. You absolutely would. You'd lose a full mark.
Even if you have the answer right.
Yep. Because you're not checking it. And just because you have the answer right doesn't mean it's not extraneous.
Well, if you want to check it.
If you checked it, then show your check. Yeah. Basically, you'd lose marks for being lazy, for sure. Yeah. All right. So we don't want that. No one wants that. Not I. All right. So before solving, we did solving last, then we did what before that? Starts with a D. Rhymes with evision. Division. Good job. Way to go. Cleared that one right up. So we're going to do the 3 different types. Now for number 2, I'm going to say simplify. And that's all I'm going to say. And I'm going to say that for every single, I'm just going to write simplify, and now I'm going to go A till the end, because every single question from now till the beginning of the unit just says simplify. And we always have to have a reduced radical. And how do you know what to do? Well, if it's division, it is dividing. If it's multiplication, it'll have a multiplication. Additions and subtractions of additions and subtractions, right? So simplify just tells you to make it more simple, to reduce it, to collect like terms, to distribute. Okay? So the first one I'm going to give you is this one. A, negative root 21 over square root 7m. Oh, I forgot to write my restrictions for this one. So I had x minus 8 under my square root, so I have to go with greater than or equal to 0. So x is greater than or equal to 8. I forgot to write the restrictions.
And you get for sausage, you get
Yeah.
for the-
If I say state the restrictions, you have to, yeah. So this question would be out of 3. 1 for this, 1 for the restriction, 1 for that. So A is that, and then B, 7 root 2 over root 6 plus 8. Try those out. So, when I have a radical in my denominator, a monomial, I just multiply by the radical, correct? Now, if I want to state restrictions, I would say what's under the square root, if there's a variable, only when there's a variable I have to state restrictions, I would say 7m technically is greater than or equal to 0. We agree? But what can't we equal in the denominator of any fraction? What number can't be in the denominator of every fraction? Nope. What can't we divide by? 0, right? We are not allowed to have a 0 in our denominator. So if this root 7m was up here, I would say greater than or equal to 0, correct? But because it's in my denominator, I only say greater than 0, because it can't equal it because it's in the denominator. And this is something that we don't have to push as much in 11, but it's huge in 12. So if you're going into grade 12 knowing that, you'll rock when this happens. So the key thing is that you can't have 0 in your denominator, and anything under a radical has to be greater than 0, right? So that's why it cuts off the equal to when your variable's in your denominator. Divide by 7, and m would be greater than 0. So that would be our restriction for this one. I didn't make you state them, just setting you up for next year. Success. So we're going to multiply by root 7m. And then we get on an equal sign. Make sure you have equal signs because everything equals each other because it's simplifying. This step equals the next step equals the next step because they're all just simplified versions of the next one. So negative 1 times 1 is negative 1. Root 21 times 7m, what's that? What's 21 times 7? (147m). And then what's root 7m times root 7m? 7m. Hence why we multiply by what it is, because the radical goes away, right?
Oh, yes.
Which is my issue. Yes, that's why we're doing this. We're doing this because we're trying to rationalize the denominator, which means make it not have a radical, which is called rationalizing the denominator. Okay? 147, can I break it down into any perfect squares? Yeah? 49 and 3? We agree? So we get negative 1 root 49 times 3 times m, which is good to have that chart, because if you have the chart, you'll work through it, right? Doesn't take very long, just boom, 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 divide them out. The 49 comes out and it's a 7. And then in the bottom, I have 7m. Now I have negative 7 root 3m over 7m. Now the 7 and the m are multiplied, are they not? They're in their own brackets, correct? So because they're multiplied and not added, I can actually take a 7 out of both of these. So this will become negative 1, and that one will become positive 1. So we'd just be left with negative 1 root 3m over m. And then we follow behind with m is greater than 0 with our restriction. B this time happens to have a what in the denominator? A binomial, right? And how do we get rid of a binomial denominator with a radical? Multiply by the conjugate, which is the same thing, opposite sign in the middle. So we're trying to rationalize the denominator. So we're going to multiply this one by root 6 minus 8. Root 6 minus 8. So when I distribute this in, I get 7 times 1, which is 7, equal sign. Root 2 times root 6 is root 12. And then 7 times negative 8 is negative 56, root 2. Over root 6 times root 6 is 6. Remember, if your denominator after you do this still has radicals in it, you did not multiply by what you should have, right? Because the point of multiplying by the conjugate is that anything with a radical symbol should disappear. Should either cancel off or go away. Now outside, negative 8 root 6. Inside, positive 8 root 6. Last, 8 times negative 8 is negative 64. And negative 8 root 6 and positive 8 root 6 cancel. And I have rationalized the denominator. I've gotten rid of all the radicals, so I know I did a good job. Okay? On the top, I can reduce 12 to 4 and 3. Take the 4 out, it becomes a 2. Minus 56 root 2. Over 6 minus 64 is negative 58. 14 root 3 minus 56 root 2 over 58. Negative 58. Now, I have 1 term, 2 terms, 3 terms. Can I take anything out of them? I think a 2. And why do I think a 2? Because all the numbers end in an even number. The last digit's even. If the last digit's even, you can divide by 2. The last digit of every number. This one's 4, this is 6, this one's 8. That's why they teach you all those little silly rules when you're younger and division rules. So when you get to this, you can do it. They all end in an even number, so they're divisible by 2 at the very least. So I can take a 2 out of here, I get a 7. I can take a 2 out of here, and I get negative 28. Take a 2 out of negative 58, and I get negative 29. Now, I want to show you one last thing, because a lot of the time, you guys, this won't be the answer. The answer will be negative 7 root 3 plus 28 root 2 plus 29. Yeah? Yeah, they're just taking out a negative 1. So this is what I need to send home to you. If your answer and the answer on the test are the exact same numbers in every single way, but every term is a different sign, it's the same answer. Because they're just taking a negative 1 out of here and moving it up to here and distributing it through. And if you don't believe me, type these 2 into your calculator. 1 in, and then type the other one in. Go. Even if you do believe me, try it. Type this one in, type that one in. Straight up into your main screen. And if you want it to be easier, type alpha y equals, enter. Make the fraction. If not, if you don't use alpha y equals, enter, you're going to have to put numerator in brackets, denominator in brackets, because that's the only way your calculator knows it's a fraction, right? So alpha y equals, enter pops up the fraction. If you don't use that or you don't have that function, if you have a TI-83, you have to put the top in brackets, divide by the bottom. That's how it knows it's a fraction. So type that in. And you should get the same decimal. If you don't, you didn't type them in right. Did you do it? So I did a division where I had monomial over monomial. I did a division where I had a monomial over a binomial. What do you think my last division one's going to be? Binomial over binomial. You are correct. I'm not even used. So I'm going to go 2 root 12 plus 3 root 2 over, what just happened? It just moved. It felt like it. 4 root 2 minus 6 root 3. And then we'll have D, which is going to be so you have C and D to do. So the first thing we should do whenever we're asked to simplify, the very first thing we should do even before we do any operations is check to see if we can do what? Reduce them. Make them smaller so we don't have to do such massive numbers, right? So the root 12, I would break down into 4 and 3. I'm just writing, oh my gosh. I'm just writing it over top because I didn't leave myself a lot of room. So I take the 4 out and I make it a 2. So I would get 2 times 2. Okay, I would get 4 root 3 plus 3 root 2. Remember, if you didn't do that, you can still have the same answer. You're just reducing bigger numbers at the end. So now we have to multiply by the conjugate because there is a binomial in the denominator. So 4 root 2 plus 6 root 3. So we get 4 root 3 times 4 root 2 is 16 root 6. Inside 3 and times 4 is 12. Root 2 times root 2 is 2. Outside, you can go either way, it doesn't matter. 4 times 6 is 24. Root 3 times root 3 is 3 in brackets. And then plus 18. Root 2 times root 3 is root 6. All over. 4 times 4 is 16. Root 2 times root 2 is 2. And then outside, 4 times 6 is 24. Root 3 times root 2 is root 6. Inside, negative 6 times 4 is negative 24. Root 3 times root 2 is root 6. So they cancel. And then negative 6 times 6 is negative 36. Root 3 times root 3 is 3.
No way I did that right.
Glad you believe in yourself. All right. 16 and 18 is going to be 34. Yep. Root 6. And then here we'd get 24. And I would normally show this in separate steps, but I'd run out of room. And then 24 times 3 is 72, I believe. 24 plus 72 is 96. All over 16 times 2 is 32. And then 36 times 3 is 90, 108. 108?
Yeah.
So 32 minus 108? I don't know. What is that? I don't want to use my brain. It's negative 96, right? No, it should be negative 90. Go to 110. Minus 30 is 80. Yeah. I was like, it needs to be less than 80. Okay. And then they both end in 2, so I can take out, or they both end in even, so I can take a 2 out. 34 divided by 2 is 17. 96 divided by 2 is 48. And then 76 divided by 2 is 35 with 3 more, so negative 38. So your answer is going to be 17 root 6 plus 48 over negative 38. What other option could I have given on the test? Negative 17 root 6 minus 48 plus 38 on the bottom. David is way too excited. All right. You need to believe in yourself. So the next one, we could do distribution right off the bat, but I'm going to reduce it first. I'm going to reduce this. So I'm going to get 2 bracket 1 minus and then 10 square root 8. I can break down into 4 times 2 times x times x times x. The 4 comes out as a 2, and then 2 x's come out as an x. And then I get 2 plus 7 root 5x. So I'm going to get 2 bracket 1 minus 20 root 2x. 2 plus 7 root 5x. And this 2 has to get distributed in, but it stops at the first end bracket, correct?
Yeah. Number C, is that the hardest it gets?
For letter C, yes it is.
No, but like in the whole like question like that.
In the whole year? No.
Like, is that like...
For this unit, yes.
Yeah. Okay.
Okay. 2 minus 40, I'm saying the whole year is a little aggressive to go that route. And then 2 plus 7 root 5x. And then we FOIL, so we get 2 times 2 is 4. 2 times 7 is 14 root 5x. 2 times negative 40 is negative 80 root 2x. And then negative 40 times 7 is negative 4 times 7 is 28 plus a 0, so negative 280. Root 10 x squared. Now the x squared can come out as an x and cancel. So we're going to get 4 plus 14 root 5x minus 80 root 2x minus 280x root 10. That's as good as it gets. Nothing matches. These ones are cube roots, so you have to watch yourself. This one's going to be negative 4. Cube root is going to be 125 times something, I believe. 5? R. 125 comes out as a 5. And then this one is going to be 8 times 5. R, 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 R. And then it's a 3 R's for 1. So the 8 comes out as a 2. And then the R's come out. So I'm left with negative 20 cube root 5R plus 2R cube root 5R. They're both cube root 5R's, so I can go negative 20 plus 2. That's actually, it's going to be, this one's, watch, this one's a little tricky. You can't put these together, they're not like terms. So it's actually going to be negative 20 plus 2R cube root of 5R. This one is going to be 9 times 2. Take the 9 out, it's a 3. Plus 9 root 7. And then this one's going to be 9 times 7. Take it out, it's a 3. So I get 6 root 2 plus 9 root 7 minus 3 root 7. These can go together. 6 root 2 plus 6 root 7.